Hey everyone. So based on a request I received from a fellow YouTube member, I decided to finally work on and upload my video providing an overview of the Raspberry Pi, as well as how to use the device as a VPN server. I previously mentioned in my VPN video that I used my Raspberry Pi as a VPN server, so I thought that I'd make this video to clarify how I achieved that. The Raspberry Pi I'm using is the original 256 MB memory one, and I've wiped everything on the memory card to take you through the steps on how to configure the VPN from the start. So here's the unit itself. Let me get it in focus. So it's pretty simple. It's about the size of a credit card unit. It doesn't use that much power. It uses about 6 to 7 watts, which is why I can leave it running 24/7 without worrying about a huge electricity bill or something like that. So the unit has GPIO pins, which you can notice on the top left. I'll show you later. But there's an Ethernet jack. That's how I plug in the unit into my router and allow it to access the internet. The unit doesn't have a built-in Wi-Fi, so you have to go through the Ethernet to power it up and connect it. Not power it, but connect it to the internet. And it has two USB 2.0 ports. Then there's a 3.5mm headphone jack, as well as an analog output if you're using an older TV that doesn't have HDMI ports. And there's an SD card slot on the bottom of the unit. It supports both SDHC as well as the older SD card formats. And to power it up, you need to plug it into a micro USB slot. And over here, you can see there's an HDMI port to connect the unit to your television set, if you have a newer television set. And yeah, if you look right there, those pins right there that's sticking out that I'm pointing to right now, those are your GPIO pins. The unit was originally designed so you can access those GPIO pins and control things such as a motor or an LED or something of that sort. If you're interested in using the GPIO pins, there are many tutorials on YouTube, that teach you how to use them, and it's actually pretty interesting figuring out how to control physical motors or things of that sort with this unit. And this unit was made, to learn programming. So it would be nice if, just take a look at the GPIO pins. It's worthwhile. So I'll flip the unit over. There's nothing really on the back besides the SD card slot. And it's not one of those fancy SD card slots. You just basically stick your card in and you'll feel a little bit of resistance. There's no clicking or anything else that you'll feel. Alright, so I slid the card in, and yeah, that is an 8 MB card that I received with my first camcorder I bought like in 1999 or something of that sort. So yeah, that's an 8 MB card. And right next to it, the card I'm actually going to be using is a class, I believe, 6 SD card, which is 8 GB card, considering the operating system requires, I think, about a 4 GB card at minimum to, store all the files on. So yeah, also I would recommend getting at least a class 6 card. I know there's a performance hit that you'll take if you use a lower class card. Class 10 card is the one that's, that will give you the highest performance. But I've noticed that the performance of the class 6 card has been, okay. So I just tend to use that since it was a cheaper card. So yeah, that's the unit. And now I'll go on how to set up a VPN server on it, as well as how to actually install the operating system onto the unit. And yeah, that's my Ethernet cable that I'm going to be using. So yeah. I've set the unit up, and now it's time to install the Raspbian operating system. To acquire the operating system, go to raspberrypi.org and click on the download section. For the purposes of this tutorial, we will be using the latest version of Raspbian Wheezy. So I'm just going to download that now. It's a 470 MB file, so it might take a while to download. Okay, so back to the website. One thing that I wanted to note is that the default logins of Raspbian Wheezy are Pi and Raspberry. So we will need to use these credentials to SSH or FTP into the unit. Additionally, in order to log on into Wheezy, these credentials will be required. So while the operating system is downloading, the next step that we need to do is to acquire the installer. We can't just simply place the downloaded archive or just place it right onto the SD card, because that won't work. We need to create a bootable SD card, and the only way to do that is to actually download the installer. A link to the installer can be found on Raspberry Pi's website in the download section. Luckily for us, at the time of filming this video, an installer with a graphical interface exists for the Mac operating system. Before it didn't, which was annoying because you had to go into the terminal window and enter commands in order to actually import the files, the operating system files, onto your SD card. If you fear the command line or terminal style of interface, I'm sorry to say that we will be working with it in a bit, unfortunately. So I'm just going to set up the installer by clicking it and then running the DMG file. It's simple as that. So when you run the installer, it'll prompt you to locate the image file for your Raspbian OS. Specify the location and click OK. Next, a prompt will ask you to insert your SD card and basically enter your SD card at this point, and the program will automatically write the OS contents onto your card. The procedure has been made quite simple, a lot more simple than it used to be back in the day when you had to enter lines in the terminal in order to write files onto the SD card. So as you can see on the screen, it's pretty simple. And it usually takes about 15 to 20 minutes, depending on the speed of your card, to write the files onto the SD card. And it'll tell you when it's completed, so you don't need to worry about pulling out your card too fast or something of that sort. So I'm just entering my administrative information, and as you can see, the program is now running. So I'll press continue, and yeah, it's working away. I don't have a spare monitor, unfortunately, so I will be SSHing into the unit. I found the IP address of the unit from my router's webpage and logged in via the admin credentials that are provided on the Raspberry Pi's website. And the program I'm using to actually SSH is Coda. It's a really nice program if you're into programming or web development or something of that sort. So take a look at it. So I'll press the connect button, and there's my IP address of the Raspberry Pi. And it should log me in with no problems. And there you go. There's a terminal window for my Raspberry Pi. That's actually my Raspberry Pi, and I can run code. So I'm going to run the configuration code, which is sudo raspi-config. And I will split the memory so that the Raspberry Pi has more memory allocated to processes and less allocated to video memory, since it's not connected to a monitor regardless. And at the same time, I'll also expand the SD card portion to fill up the entire SD card. Because initially, I think it only fills up 4 gigabytes. If your card is like 8 gigabytes, you might want to expand the SD card portion so that the operating system can use the entire SD card and space that it has. And yeah, I'm also going to overclock the unit so I get a little bit more performance out of it. So yeah, that's done. And lastly, I'll also update the Raspi config program so that I get all the new settings. This takes quite a while. The unit isn't incredibly fast. It's running on a V7 ARM processor, running at like 700 megahertz or something of that sort. So give it its time. It's going to be pretty slow. So the system just finished updating, and I entered the top command to view my resource utilization by the operating system. And everything seems to be normal, so now we can move on with the VPN installation step. The first command that we're going to run is sudo apt-get update. This updates the repositories and acquires the latest versions of packages and their dependencies. Once again, this process is going to take a while, so grab a coffee or just sit around until it's done. Once the repositories are updated, the next command to enter is sudo apt-get upgrade. This command is usually paired with the update command and fetches new versions of packages existing on the machine. It'll ask you if you want to continue. Just press Y, which stands for yes, and it'll update all the packages. Now comes the installation of the VPN services. We will be using a PPTP based VPN, and the code to install this service is sudo apt-get install PPTPD. And once again, it's going to install the packages, and it'll take a couple of minutes depending on your connection speed as well as the Raspberry Pi speed, whether you've overclocked it or not. Once the PPTP VPN service has been installed, the next thing to do is configure it. To do this, enter the command shown on the screen, which is sudo nano /etc/pptpd.conf, and you'll be presented with a similar window. The next thing that we need to do is to scroll to the bottom of the file that we just opened. Since your mouse does not work in the SSH session or in the terminal, this can be done by hitting the down arrow key or by hitting page down. At this point, we're interested in uncommenting and modifying the local IP and the remote IP lines within the file. The local IP refers to the IP address of your Raspberry Pi. If your Pi has not yet been assigned a static IP address, I would highly urge you to go into the router's administrative panel and set a static IP address to the unit. The remote IP address, on the other hand, specifies the IP address range that your Raspberry Pi unit will give out to clients connected to it. In my case, I just modified my local IP and I was good to go. Since I've already gone into my WNDR 4000's administrative panel and set a static IP address route for my Raspberry Pi. Also, one last thing, make sure you save the file when you exit in order to commit any changes. Otherwise, the uncommenting that you did for the local IP as well as your remote IP will not, be finalized. So on the screen right now, I'm just basically going through my administrative panel on my router and setting a static IP address for my Raspberry Pi unit. Okay, so the next step that we need to take is to configure the PPTPD options file and add the paragraph of code that is seen on the screen to the bottom of the file. So that's the code that you need to enter in order to bring up the PPTD options file. Wow, that's a mouthful. And okay, so we're going to do that now. So once again, we need to go to the bottom of the file and add the paragraph of code that was seen on the website. So this paragraph of code that I'm highlighting at the moment. And we'll paste it right into the window. Okay, right there. The MS-DNS value, the one I'm currently highlighting, is actually the IP address of your router, which is going to be your DNS gateway if you're at a home or residential network. So change that value to whatever your IP address of your router might be, and then save the file. Yep, and that it's highlighted on the website as well. Now we need to add a user that we can use in order to log into our VPN from a remote location. To assign a user with the permission to use our Raspberry Pi as a VPN, enter the code sudo nano /etc/ppp/chap-secrets, which you can see on the screen at the moment. The format for a user is to enter the username, then hit the tab key, then enter an asterisk, then hit tab again, followed by the password. And then once you have the password, you replace that with, you hit another tab key and then enter another asterisk. Save the file once the desired user has been added. So at this point, we need to restart the PPTP VPN service, and you do that by running the command that was shown on the screen, which is sudo service pptpd restart, and it'll restart fairly quickly. So the next step with respect to the Raspberry Pi's VPN service is allowing VPN clients from remote locations to see SMB shares and other network attached storage that might be on your network. To do that, enter the command sudo nano /etc/sysctl.conf as seen on the screen, and press enter. And basically go along the file, and there'll be a line that says net.ipv4.ip_forward equals 1. Uncomment that line and save the file, and that's all you need to do in order to allow VPN clients to see network shared resources. And again, you're gonna have to apply the changes by entering sudo sysctl1-p. So go back into your shell window and enter that into there and press enter. The last step in configuring the VPN service in Raspberry Pi is assigning the port 1723 to your Raspberry Pi. The Raspberry Pi needs to accept connections on this port in order to allow clients to connect to the VPN service. So in my router's interface, I just basically assigned the VPN service and the port number to my Raspberry Pi, and everything should be functional now. Before we end the tutorial and I demonstrate the VPN service running on my Android device, I thought it would be useful to include a tutorial on configuring the Raspberry Pi to utilize No-IP. No-IP is a free service that will allow you to connect to your device without having to specify your external IP address within your VPN's client settings. You can just remember the simple URL instead and connect to the Raspberry Pi. Additionally, if you have a dynamic IP address, which is an IP address that changes every couple of weeks, using No-IP to automatically sync the IP address with the domain name is valuable, as it means you do not have to consistently update your VPN client with the new IP address, since the old IP address will no longer work after a few weeks. If you have a static IP address, you can just go ahead and set that up once on your VPN client, and you probably won't have to update it ever until you lose that static IP address because you stop paying for it or something like that. So I've already gone ahead and added my IP address, my external IP address, to a URL. So at this moment in time, I can just type that URL into my VPN client and enter the credentials that we specified in the previous steps in order to connect to my Raspberry Pi's VPN service. However, the next step is, how do I update that IP address automatically that No-IP knows of when my dynamic IP address provided by my ISP changes? To do that, we're going to look at a tutorial. You can either download a client in your Mac OS X or Windows system and it'll automatically update the IP address, or you can go the more geeky way and actually incorporate No-IP into your Raspberry Pi device so that it'll automatically update the IP address on the Raspberry Pi without having to install a client or anything onto your Windows or Mac computers. So this is a tutorial that I found on the internet that tells you how to install the No-IP client onto the Raspberry Pi. So I'm just going to do that really quickly. And I'll provide links to all of these tutorials in the description for this video in case you're one of those people who, uses the video as a reference but is more comfortable with actually following a written tutorial.